Lines, segments, and rays that are perpendicular intersect at right angles. So we can see in this picture here that we have a line segment AB and a line segment CD, and the little square marking where they intersect indicates that they've formed a right angle. When I see a right angle here, I know that because this 180 degree angle has a 90 degree angle on this side, it also has a 90 degree angle on this side. So in fact, both of these angles are right angles. So when I read my statement, I say if segment CD is perpendicular to, let's take a note that says that this is perpendicular to, is perpendicular to segment AB, then what we're going to state is that these two angles are right angles. We are going to need to name them. So we're going to say that angle CDB, so that's the angle on the right, we're going to say that angle CDB, and on the left I have angle ADC, angle ADC. Let's actually call it CDA, angle CDA, are right angles, are right angles. Now, because they're right angles, and they both measure 90 degrees, they both have the same size, we know that they're congruent. So we're also going to make this statement that says that angle CDB is congruent to angle CDA, and that's by what we'll learn later, the right angle congruence theorem, that tells us that all right angles are congruent. Let's also write the statement that the measures of those two angles, CDB, are equal to 90 degrees, because the angle measure of a right angle is 90 degrees. So we're going to say that the measure of angle CDB and the measure of angle CDA are equal to 90 degrees. When it comes to being perpendicular, we can also bisect our segments. So we have perpendicular bisector when we talk about that. So the picture below tells us that given line RT, there's the two arrows on top of those letters, tells us that it's a line segment, a line. So line RT is the perpendicular bisector of, so RT is the perpendicular bisector, he's going to stay the same, of PQ. So he bisects PQ, of PQ. PQ is the segment that gets bisected, cut exactly in half. So we have two things going on. Because RT is the perpendicular bisector of PQ, the first thing I know is I have a right angle. Not only do I have a right angle here in that top right corner, but every other angle here is also a right angle. The other thing I know is that because it's the perpendicular bisector, segment PQ, the segment that got bisected, has been split into two congruent segments. So we're going to say that angles RSQ, QST, let me put the angle marking there, angle QST, I'm just working my way around here, angle TSP, and then finally PSR, and angle PSR are right angles. We could choose any one of those two angles to say that they're congruent. I'll start with the first two that I have there. I would say that angle RSQ is congruent to angle QST. And we could keep that going and say that it's also congruent to TSP, is congruent to PSR. All four of these angles are congruent because all four of them are right angles, and all right angles are congruent. The other statement we're going to make is that the two segments have been split into congruent parts. So we're going to say that segment PS is congruent to segment QS because segment PQ was bisected by line RT.